Okay, so this video is for our end of year foray into fractions, and we're going to apply those fractions with some trigonometry. And so this lesson is going to cover a review of SOHCAHTOA and introduce what are called the reciprocal identities. So we're going to dive into some trigonometry here at the end. So as a review from geometry, SOHCAHTOA is an acronym to help you remember the basic trig functions. So in a right triangle, the longest side, which is across from the right angle, is always called the hypotenuse. If you look over here on the right, I'm going to mark in, the left. I know directions. So this is a right triangle, and it's characterized by the right angle there, and that is supposed to be the perpendicular symbol. I don't think I did a fantastic job of writing that. I believe I could do that better. So that's the right angle, and if you go across the triangle from the right angle, that side is always called the hypotenuse. So hypotenuse. And sometimes it's defined as the longest side in a right triangle. Sometimes it's defined as the side across from the right angle. The right angle is the largest angle, and so the longest side is always opposite the largest angle, and that's one of your theorems from geometry. When starting trigonometry, we define the other two sides relative to one of the other angles. And so we're going to use this symbol right here. This is the Greek letter theta. And I know that in your geometry class, you would often label your angles with a capital letter. But typically when we're doing trig, we use Greek letters. And so that little circle with the line going across it is the Greek letter theta. And we can pick either of our other two angles. So you can pick like this angle up here or this angle down here. You just need to know where in the triangle you are. So I'll go ahead and put theta right there. Okay, and I could have just as easily put it on the other side. And so the other two sides are defined relative to this angle, and they are called the opposite side and the adjacent side. The opposite side will be across from the angle, and so we go across here, and that will bring us to the opposite side. And I'll define this as opposite is across from the angle. And then the other side is the adjacent side. And the word adjacent means next to. So if you look in the classroom and you might say, who sits adjacent to you? It would be asking who sits next to you. And adjacent could mean like next to you, side to side, but it could be like a front to back next to you as well. And so the adjacent side is the side next to the angle, but not the hypotenuse, because the hypotenuse would also be next to the angle. So if we take a look at that, so here's angle theta, and there's two sides that are next to that angle. One of those sides is already labeled as the hypotenuse, and so the other side would be the adjacent side. And so we end up with these three sides. We have the hypotenuse, the opposite, and the adjacent. And if you look at the acronym, we have O's, H's, A's, and H's, O's, A's. And the O always stands for the opposite side. H is always the hypotenuse. A is for adjacent. And then the letters define the trig functions. It is really important that you spell SOHCAHTOA correctly. It's been a long time since I've taught geometry, but I remember kids spelling SOHCAHTOA like SAHCAHTOA, SAHCOTOA, SOHCAHTOA, SAHCAHTOW. Okay, like you've got to get the letters in the right spot. So SOHCAHTOA is just this little like acronym. It kind of rolls off our tongue, but you do need to know how to spell it, or it actually doesn't work. All right, so again, I mentioned the first letters, the S, the C, and the T correspond to these three basic trig functions, which are called sine, cosine, and tangent. And these are always defined with a specific angle in mind. So you never just have like sine just by itself. Now, when we're first defining them, we probably don't put the angle there because we don't necessarily know where we are. But the sine of an angle is O and H. It is defined as the ratio of the opposite side to the hypotenuse. And so there's your SAW, S well, let me pick a different color. So you've got the S for sine, and then you have O and H, and that's your SOH, your SAW. So sine is opposite over hypotenuse. Cosine is your C, and you'll see that that goes with A and H, and we know that A is the adjacent, and so this is the adjacent over the hypotenuse. And again, the cosine of a particular angle, it's always got to be of a particular angle, because if you don't have an angle, then you don't know where the adjacent side is. You don't know which side is the adjacent, which side is the opposite. And then tangent is our last letter out there, and you'll see that's OA. And so that is the ratio of the opposite to the adjacent. So if you can remember SOHCAHTOA, then you would always have those ratios. And these are always defined with that specific angle in mind. So if you don't know which angle it is, so if I pick this angle up here, then this side is the opposite and this side is the adjacent. But if I pick this angle, okay, then it would be the other way around. So you're opposite and adjacent. So you always, always, always have like an angle in mind. So it's always the sine of an angle or the cosine of an angle. Do we get lazy about that sometimes when we're doing other kinds of problems where we're not staring at a triangle? Yes, we do. But just we need to acknowledge, like, yes, we're being lazy about it when we do when we do that. She says as she chokes. So here's a specific example. So if you take a look at this, we have a 5, 12, 13 right triangle, and then here's our angle theta. So we have put our angle theta in a specific spot. Again, we have to know where the angle is. So the sine of angle theta would be SAW. Okay, so we'll do like a little bit of scratch work here. So that's SAW. So that's going to be the opposite side over the hypotenuse. So you start at that angle and you cut across. So the opposite side is 5. And the hypotenuse in this case is 13. So the sine of that angle is 5 over 13. It's that ratio. Cosine is going to give me, that's ca. So that'll be the adjacent over the hypotenuse. And so we've got two next to sides, but the 13, the longest side, is the hypotenuse. So the adjacent must be the other one. So the adjacent in this case is 12 over the hypotenuse, which is 13. And then tangent is going to be our TOA. And so we would take the opposite for that angle, which was 5, and put that over the adjacent, which is 12. And hopefully when you took geometry, you did some of this, just practicing with these ratios. Now, when you STUI, also known as the D key on your keyboard, doesn't work all the time, study similarity in geometry, you learn about angle-angle similarity. And so that means that if you have any two angles that are the same, then the triangles are similar. And so in a right triangle, you automatically have the right angle, okay, is going to be the same. So if you have two right triangles, just by virtue of the fact that they are right triangles, means that you share the 90-degree angle. And then if you have the other angle the same, so that means like for any like 50-degree angle, so you've got a 50-degree angle, then those triangles would be similar, and similar triangles always have those same ratios. So this means that these ratios will be true for these angles, even if the triangle itself is bigger or smaller. When you take the ratio will end up being the same. So it's like instead of having 1 over 2, you might have 6 over 12. So the numbers would get bigger or potentially smaller, but the ratio between them would be the same. Like 6 over 12 is the same ratio as 1 over 2. So this is just kind of showing you that. If you watch that video, hopefully it's recording okay. I did this in Fusion 60, and I put a 50-degree angle there. How keeping the 50-degree angle, as long as that 50-degree angle is locked in, it causes every side of the triangle to change when we change one side. So like changing one side, like it moves everything else, and that's what keeps the ratios the same. Okay, so your sine, your cosine, your tangent ratio is going to be the same because both of the numbers are going to go up, or both of the numbers are going to go down, and they're going to go down and up by the same amount that keeps the ratio the same. So the sine of 50, the cosine of 50, and the tangent of 50 will always be the same number. Not that they're equal, so the sine of 50 and the cosine of 50 are not like the actual same number, but what I mean by that is if you have like a small triangle with a 50-degree angle in it and a big triangle with a 50-degree angle, the sine of 50 will be the same for both of those triangles, and the cosine would be the same for both of those triangles, and the tangent would be the same for both of those triangles. Not that sine, cosine, tangent are the same like to each other. And your calculator can calculate those for you. So if you have a calculator, you could put into your calculator sine of 50 and it'll spit out some kind of decimal, no matter what, because the sine of 50 will always be the same. The ratio of the opposite over that hypotenuse, that ratio is the same whether that triangle was bigger or smaller. All right, so try these on a separate piece of paper. Yeah, try these on a separate piece of paper. So if you're doing this from home, grab a piece of notebook paper and do sine of theta, cosine of theta, and tangent of theta for that triangle. That's a 6, 8, 10 triangle. And pause the video. And then we have what is sine theta over cosine theta? And what do you notice about that? So pause the video and see what you can do with this. All right, so I'm not going to go over those first three because I think if you need to rewind the video, like go and rewind the video and see how I did that on the previous slide. But I do want to take a look at this one. So sine of theta over cosine of theta. So sine of theta is the opposite over the hypotenuse, and the cosine of theta is the adjacent over the hypotenuse, whatever those numbers are. So you could have like a totally different triangle with different numbers in them, but you would still have like opposite over hypotenuse over adjacent over hypotenuse. Now here's what those fraction skills. I've been talking about fractions at least this year a lot, like how we really need to get like good at fractions. So to divide by a fraction means to multiply by the reciprocal. So watch what I'm going to do here. We have opposite over hypotenuse, and I'm going to write divided by adjacent over hypotenuse. All right, so I just took that fraction bar right there and replaced it with a division sign. But to divide is to multiply by the reciprocal. So we have a over h, so I'm going to change division to multiplication and then take the reciprocal of that. And then if I multiply and divide by the h's cancel out, leaving me with O over A. And what do you notice about O over A? Opposite over adjacent. What is equal to opposite over adjacent? Well, that happens to be tangent. Tangent is opposite over adjacent. And hopefully you notice something like that. If you need to go do like a quick little revision on your work for number 4, pause the video and do a quick little revision. Do it in a different color. Okay. Like I understand if you're doing this from home because you were absent, that you might have made some mistakes, and it's I'd actually rather see what you did and then your correction than for you to just like breeze through it and try to make everything look perfect. All right, so this is what's called a trig identity. I mentioned we were going to talk about reciprocal identities, that the tangent of theta is equal to the sine of theta over cosine of theta. And this is incredibly common. When you study trigonometry, you will deal with this so often. I can deal with it all the time. So that we have like sine of theta or tangent is equal to sine over cosine. And we essentially just proved that. Like we went through the O over H over A over H, and we did the simplification to that, and we got O over A. So the sine, the saw over the ka is equal to the oa, the toa part. And so that is what's called a trig identity. What that means is that in any kind of problem, if you were simplifying, you could take tangent and replace it with sine over cosine. And again, notice that it is a fraction. And so we see a lot of fractions in our trigonometry. If you hear voices, it is the janitors are doing their cleaning, so they might come in at some point. So what are trig identities? Trig identities are relationships between different trig functions. There are probably about 24 of them total. I was trying to think earlier, like how many there are. There's the reciprocal ones, which we're going to look at in this lesson, but there are also what are called the Pythagorean identities. I kind of touch on that at the end of this lesson. But then there are what are called sum and difference formulas and double angle formulas. Like if you double the angle, what's the relationship there? So there are actually quite a few. I mean, 24 might be a lot. It might be just closer to like a dozen without me like diving in and trying to think about all of them. One skill that is developed in the study of trigonometry is the ability to simplify and rewrite trig expressions using the identities. And so you can make them bigger or smaller or rewrite them. And a big push in the new AP pre-cal is what are called equivalent expressions. So you take an expression written with some trig functions and rewrite it using other ones. Some of them are much more commonly used than others. So the tangent is sine over cosine. That is maybe the most common one that you would see, but the one of the Pythagoreans is very, very common too, and they're probably the only ones I can really remember. That and the reciprocal ones. So there might be a list of about 6 of them that if you can remember those 6, you'll probably be pretty good. So how does this connect to fractions? We are about to start several lessons that will review fractions, at least the year that I'm recording this. So if I have assigned this video in a future year, like maybe we have something different planned for what's coming up. But at least this year, we're going to do several lessons that review fractions, how to add them, subtract them, multiply them, divide them. Like what are they? How do the numerator denominators work? While those basic skills are elementary level, like maybe 4th through 6th grade, their applications extend into things like simplifying and operating on rational expressions and trigonometry. So if we finish the school year out, like you know that we've looked at things like this, where you might have these expressions. So x plus 5 over x plus 3, and you need to know that the x plus 5s cancel out. And maybe we've done some things where you've added stuff that have all those, factors in them and multiplied them, and you've got a factor, and then you find the common factors. And so those fraction skills that you learn back in 4th through 6th grade come into play in this higher level math. Now, we've already covered, at least this year, the rational stuff, and I don't necessarily want to go back and rehash that. Those here are very loud. I think that's a toilet flushing. I don't know if the microphone is going to pick that up, but it's fun. I don't want to go back and hash all that out. So I want to apply it to something new. Either way, it would be a good review or a good gear up for pre-cal. So there are 3 reciprocal identities that are just generally memorized. I think I might try to find what's called the hexagon. I might try to introduce you guys to that. One of the teachers uses that. One of the pre-cal teachers uses it. But I just memorize these, and I'll kind of tell you how I memorize them. So they are secant, cosecant, and cotangent. Okay, those they are. The abbreviation for secant is SEC, cosecant is CSC, and cotangent, hello, is COT. So that's secant, cosecant, and cotangent. Here's what I memorized. So you already have sine, cosine, and tangent. Okay, every trig function goes with like a co-trig function, and so tangent and cotangent go together. Okay, so you have a function and a co-function, and then you already have sine and cosine. So these ones are kind of flip-flopped. So sine goes with cosecant because every trig function goes with a co-trig function, and cosine goes with secant. Okay, so you've already got the sine and the cosine, and those go with secant and cosecant, but again, every function pairs with a co-function, and then the tangent and the cotangent go together. And I just remembered it from there. So secant is defined as the reciprocal of cosine. Okay, remember reciprocal means to flip the fraction over. And so secant is 1 over cosine. Cosecant, so secant is 1 over cosine. Cosecant is 1 over sine. Again, every co goes with something that's not a co. So secant goes with cosecant, something that has a co in front of it. Cosecant goes with sine. And cotangent is the reciprocal of tangent, which is 1 over tangent. And once again, you see that the introduction of these fractions coming in and what we might do with them. Those generally just need to be memorized. And I showed you how I do it, just like a co with a non-co, and then tangent goes together, and then the other two have to be flip-flopped. And that has worked for me for my life. But I'll see if there's some tools that I can give you that might help you memorize those. So try these on your own paper. So some of these are going to be the same. I will go over a couple of these just to spot check, but pause the video and see if you can get these on your own. All right, so I'm going to look at number 5. So 5 is the cosine of theta. So if we go back to SOHCAHTOA, cosine is adjacent over hypotenuse. So cosine, if I go find my angle, there's my angle, and I want the adjacent side, which is 24, over the hypotenuse, which is 25. Now I'm going to jump down to secant, okay, because cosine and secant go together. Well, secant is 1 over cosine, and cosine is 24 over 25. So you've got 1 over 24 over 25. Now you could do this the long way. I'll do it like the long way one time, but you don't want to do it the long way every single time. So we have 1 over 24 over 25. That's 1 divided by 24 over 25. But remember, to divide means to multiply by the reciprocal. So it's 1 times 25 over 24, which of course is 25 over 24. And what I want you to notice is that these are reciprocals. So if cosine is 24 over 25, secant is 25 over 24. It's the reciprocal. You're just flipping it over. Again, hence why they are called the reciprocal identities. So if that helps, go ahead and like check your answers again. And remember that tangent and cotangent are going to go together, and sine and cosecant go together. So if you've got sine, cosine, and tangent in that first batch, then these are going to be the reciprocals. Sine over cosine, we already established was equal to tangent. So whatever you got for tangent would also be your sine over your cosine. So whatever you have for 6 should also be what you have for 7. So double check that. And then this last one, cosecant times sine. Cosecant times sine. Well, kind of reason this out. Cosecant is 1 over sine. That's the definition of cosecant, times sine. And what's going to happen here is you've got multiply by sine, divide by sine, and it should come out to a 1. Now, you might have done that with actual numbers. So you might have that with like the actual number that you have for cosecant and the actual number that you have for sine. So maybe you have like 25 over 7 times 7 over 25, but then you end up with something divided by itself, and you should end up with a 1 either way. And pause the video again right here if you need to make some changes. Don't erase your work. Just grab like a pen or pencil that's a different color and just make some changes to what you did. I would so much rather see that than for you to just breeze through, photomath it, like all that. All right, and explore further. So without looking at a triangle, what do you think numbers 13 and 14 could be? So these would be done in a similar way to the one that I just did. And what I intend to do in class is to just see what students can do with this. So if you know that tangent is, or you got tangent and then cotangent is 1 over tangent, what do you think would happen there? Okay, and then we have sine theta times cosecant theta. Now we actually just did that. It was the other way around. We had cosecant times sine, or cosecant times sine. This is sine times cosecant, but that's the same thing. And we know secant is 1 over cosine. So I'm giving you some like hints and like a direction you might go. Give it your best shot. Give it your best shot. If you want to like use AI after you give it a shot, you can knock yourself out. Okay, so do what you think. Do that in pencil, and then if you want to use AI, dump it into AI, and then in a different color, right? Miss Taylor, this is what AI told me. So my work, and then my AI check, and just put that over there. I honestly not going to take off anything for that. Just show me what you did first, and then show me what AI did, and then like maybe ask me a question in the margin. That would be perfect. That would be ideal learning. For 15, use the triangle at the right, which at the moment is covered by my face. So I think I can turn that off. Maybe. Actually, I don't think I can. There's a button to turn it off up here, but it's not giving me the option to turn it off. So that's awesome. I can resketch that for you. It is a 3, 4, 5 with theta down there. So I want you to try, like, what is sine squared theta plus cosine squared? And the squared might look like it's in a very weird spot, but that just means like sine theta times sine theta. We just put this square on the sine. We don't put it on the theta because that looks like you might be squaring the actual angle, which we're not doing. We're just going to do sine theta times sine theta plus cosine theta times cosine theta, and do that out and let me know what you get. And same deal, if you want to do it out and then look at the AI, just do it in a different color, and that would be awesome. So you should be able to, once you've done this on separate paper, upload this to Focus if you are doing it from home, or if you're like rewatching it, you can like bring it into class the next time. But hopefully you found this a little bit interesting. It's very, very different from the stuff that we've been doing. And as always, you know how to find me. Send me an email, post something on Teams, whatever we need to do to ask me any questions if you are stuck. I'd be happy to help, and I will see you in the next video if we have a next video this year.